What I want to talk about is mantle plumes and how they relate to flood basalts and chains of ocean islands. But before I can do that, I need to talk a little bit about viscosity for those of you who haven't come across this term. A high viscosity fluid is a fluid that doesn't flow very well, and a good example of that is honey. A low viscosity fluid is a fluid that flows easily, and water is a well-known example. If you put honey in the fridge, it becomes very viscous, whereas if you take it out and heat it, it becomes very low viscosity, or its viscosity decreases. And this is important because temperature has a very profound influence on viscosity. And that's true of honey, it's also true of the mantle. And it very much affects the way the mantle behaves and the way and it also affects how mantle plumes behave. Mantle plumes are responsible for flood basalts, and a very good example of a flood basalt is the Deckhand Traps. And this first slide shows a picture of the Deckhand Traps. And you can see flow after flow. You can see them in the foreground, in the middle ground, and in the distance. And these flows, with almost nothing in between, are over 1,000 meters thick, and they extend over an area of about 2,000 by 2,000 kilometers. There are a number of flood basalts known in the geological history. They occur about once every 10 to 20 million years. Another good example is the Siberian Traps, which is obviously in Siberia, and they are responsible for the biggest mass extinction in the geological record. The second biggest mass extinction occurs 65 million years ago in association with the eruption of the Deckhand Traps, and it was responsible for the demise of the dinosaurs. So what are mantle plumes and how do they work? This is India 65 million years ago when the Deckhand Traps erupted. The red spot shows where the centre of the Deckhand Traps plume was. The Deckhand Traps are in India, and part of the Deckhand Traps plume is the Seychelles Islands, which are currently not part of India, but were at the time that the Deckhand Traps erupted. This is what the Deckhand Traps looks like today. The current position of the hotspot is at Reunion Island. Notice that the Seychelles are no longer connected to India. They've been separated from India sometime after the Deckhand Traps by a spreading centre shown here. Notice that there's a chain of volcanoes extending from Reunion to the Seychelles and from below the Deckhand Traps towards the spreading centre. It's not Reunion that is moved, it is the Seychelles and the traps that are moved. The Reunion plume, or the Deckhand Traps plume, has remained stationary, and it's plate tectonics that have moved the Deckhand Traps away from the Seychelles, and both the Seychelles and the Deckhand Traps away from Reunion Island.